Welcome to Spaceverse, your portal to cosmic adventures. Imagine this: drifting quietly through the cold, dark space between Jupiter and Neptune is a frozen oddball, not a planet, not quite a comet, but something in between. It's called a centaur, and it's basically a cosmic mashup from the early days of our solar system. Now picture this icy loner suddenly bursting with jets of ancient gas, like a space volcano throwing a tantrum after 4.5 billion years of silence. That's exactly what astronomers saw when they pointed the James Webb Space Telescope at one special centaur named 29P Schwarzmann-Wachmann 1. Turns out, this quiet little ice ball wasn't so quiet after all. It's been hiding secrets from the solar system's birth, and it just started talking loudly. So buckle up, because we're about to dive into the wild story of how this frozen relic became a cosmic fireworks show, and what it's teaching us about the origins of everything we know. Centaurs are a strange breed. They're icy bodies that orbit the Sun in the vast region between Jupiter and Neptune. They're not as distant as the Kuiper Belt objects, like Pluto, but they aren't quite comets either. You can think of them as cosmic nomads, drifting between two worlds, both literally and metaphorically. Scientists believe that centaurs originally came from the Kuiper Belt, that icy, distant region beyond Neptune where the leftovers of planetary formation still linger. Occasionally, these objects are pulled inward, destabilized by the gravitational tugs of Neptune or even by distant passing stars. Once they begin their journey inward, they fall into the gravitational domain of Jupiter, which can sling them closer to the Sun, eventually transforming them into short-period comets, the kind that orbit the Sun in under 200 years. So, in essence, centaurs are the missing link between ancient, frozen bodies in the outer solar system and the active, glowing comets that swoop close to the Sun. More than 500 centaurs have been discovered so far, but astronomers believe there could be as many as 10 million out there. That's where NASA's James Webb Space Telescope comes in. With its unprecedented infrared vision, it can see what no telescope has seen before. And it just turned its gaze on 29P Schwarzmann-Wachmann 1 of the most active centaurs known to science. 29P isn't some fresh new discovery hiding in the shadows of the outer solar system. In fact, astronomers have been keeping tabs on it for quite a while, and for good reason. This icy oddball has a wild personality. Every 6 to 8 weeks, like clockwork, it explodes with jets of gas shooting out in random directions. Imagine a cosmic lawn sprinkler crossed with a firework, just spinning and spewing material from deep within. It's as chaotic as it sounds, and scientists love it. Before the James Webb Space Telescope entered the scene, telescopes using radio wavelengths had already spotted something curious: a single jet of carbon monoxide aimed right toward the Sun. That alone was pretty fascinating. It hinted at internal activity deep beneath the icy surface. But just when astronomers thought they had a grip on 29P's outbursts, along came JWST's near-infrared spectrograph, better known as NIRSpec, and it basically kicked the door wide open. Suddenly, that one lonely jet, it turned into a whole party. What Webb saw next didn't just deepen the mystery, it rewrote the script entirely. 2 of them are carbon monoxide, one pointing toward the Sun as previously seen, and a second one shooting north, perpendicular to the solar system's plane. But then, JWST revealed something never seen before: 2 carbon dioxide jets. One pointing north, one pointing south. This begs a critical question: what is powering these jets? On typical comets, jets are triggered when the Sun's warmth vaporizes water ice just beneath the surface. The resulting pressure bursts through, creating a spectacular display and releasing other gases like carbon monoxide and carbon dioxide along the way. But there's a problem: 29P is too far from the Sun for water ice to do that. JWST found no water vapor in the jets. So the classic model of sunlight-driven sublimation? That's not what's happening here. The outgassing is not driven by water. It's something else. So what is causing the jets? That remains one of the big mysteries. But there's a growing suspicion 29P might not be a single object at all. It could be a contact binary, 2 separate bodies that have gently collided and stuck together. Think of a cosmic snowman, with each lump made from different material in history. This idea isn't new, it's gaining traction across solar system science. The Rosetta mission's target, Comet 67 Churyumov-Gerasimenko, turned out to be a contact binary. So did Arrokoth, the Kuiper Belt object visited by New Horizons on New Year's Day in 2019. And now 29P might be part of that same club. The researchers modeled where the four jets are emerging from, and they appear to originate from different locations. Not only that, but the composition differs too. One area rich in carbon dioxide, another in carbon dioxide. That's a strong hint that these areas formed separately, evolved separately, and later merged, possibly billions of years ago. If that's true, 29P is a hybrid time capsule, made of at least two distinct ancient solar system relics. As Geronimo Villanueva, associate director at NASA's Goddard Space Flight Center, put it, maybe two pieces coalesced together and made this centaur, which is a mixture between very different bodies that underwent separate formation pathways. It challenges our ideas about how primordial objects are created and stored in the Kuiper Belt. Let's pause for a moment and reflect on the bigger picture. Every time a centaur like 29P outgasses, it's like opening a valve to the 4.5 billion-year-old solar system. These gases, trapped since the time planets were forming, carry with them the chemical blueprint of our system's early days. And unlike asteroids or Earth rocks, which have been altered by weathering, impacts, and geological activity, these centaurs have been frozen in time, literally. They are untouched. They are raw ingredients. That makes 29P's activity not just exciting, but profoundly important. It's like getting a chemical fingerprint from a cosmic museum piece that dates back to the very origin of our planetary neighborhood. So, what's next? The James Webb Space Telescope will keep watching 29P. Scientists want to see whether the jets turn on or off, or perhaps change direction as the object rotates. That could reveal how the jets are connected to surface features, or how deeply the gases are buried beneath the crust. It's a slow, methodical process, but the reward is nothing short of revolutionary. As we decode the behavior of 29P and other centaurs, we're gradually reconstructing the birth of the solar system, piece by icy piece. We are seeing in real time the leftovers of planetary formation awaken after billions of years of deep freeze. And with each jet, each burst of carbon monoxide and dioxide, the cosmos is speaking to us about its past. All we have to do is keep listening. If you enjoyed that glimpse into the mysterious world of centaurs, make sure to stay tuned. Out here at Spaceverse, we're just getting started peeling back the layers of our cosmic history. Don't forget to like, subscribe, and share the wonder. Until next time, keep looking up. The universe has stories to tell.